So here it mean the below details are details the below so the below slide details the design, implementation, and evaluation of a long short-term memory neural network developed to predict stock prices of Apple. The model architecture is specifically tailored to capitalize on a sequential nature of stock market data using a sequential model approach. First, let's talk about the LSTM architecture diagram, which you can see on the right side. So you can see here you can see an input, output, and you can see an LSTM network, and we can see that it has two hidden layers. This is the architecture we are going to consider. So now let's talk about the data set and a little on pre-processing steps. So the data sets consist of a historical stock prices of Apple. We are mainly focused here on adjacent close price, which is the only one variable which is the vital indicator in the stock analysis. So the data source is from the Yahoo Finance. So to ensure the quality of the data, and the following process steps were performed. First, the step we did was cleaning. Initial inspection of the raw data was conducted to identify missing values or outliers that may disrupt model training, which were then fixed or removed from the data set. So the shape of the data set is 1, 2, 5, 9 and 1. So the aim of this whole project was to select a data set above 500 points. So, and the third one is the feature selection. Here, out of all the features present in the data set, we only selected the adjacent close because its ability to represent overall value per share after taking into account different corporative action, thereby making it more suitable for prediction tasks as compared to the others. So the fourth one we did was min-max scalar normalization was applied on the selected variable so as to bring them in the range of 0 to 1, such that the neural network get easier convergence and training stability during the computation. So now let's talk about the core parameter selection. So we selected number of the LSTM layers, which is the hidden layers, is 2. Number of the neurons in the first hidden layer is 100. The number of the neurons in the second LSTM layer is 50. Number of the dropout layers is 2. Dropout rate is 30%. Length of the time series input sequence is 150 days. Batch size of training is 32, and number of echoes for training is 50. And the loss function used is mean squared error, and the optimizer is Adam, and we did consider the 75-25 train split for the model validation. So as I told you, the design, as I explained you the design, now let's go to the model training and evaluation. The model underwent a training over 50 epochs with a batch of 32. The Adam optimizer was used for its efficiency in updating network weights, and mean squared error was employed as a loss function. Upon training completion, the model was evaluated using the dataset, resulting in a test loss of 0.000795, indicating a high predictive accuracy on an unseen data. So after that, what we did was we did the retaining and forecasting. After the evaluation phase, the model was subjected into the retaining using all the available data. This technique ensure the prediction are made on a wider range of information to improve accuracy. This is widely used in a practice because of its enhanced prediction. So the result visualization, you can see on the right side there is a graph. Here. It shows the prediction versus the true value. The blue, as I told, will be the true value, and the orange is the prediction value. We can see that the LSTM has done a pretty good job in predicting because it's almost same, and the loss is also very, very less. So now let's go to the next slide. So here we are mainly concentrating in this slide, we are mainly concentrating on changing the core parameters and seeing if we can improve the Apple stock prediction. So as I said, the same data was used, which is the Apple stock price, which we took from the Yahoo Finance. The same data cleaning steps were done, which I told you for the previous one. So checked if there is any missing values, and the data shape was 1, 2, 5, 9 slash comma 1 again. So and in the future selection we use the adjacent clause because we think that is the most important variable to be considered, and scaling down we use the min max scalar was applied on the selected variable so as to bring the 0 1. And you can see the architecture here. We are considering the 3 hidden layers. So let's talk about the more on the parameters. So what I considered here were, for the data of testing, I used a 20 test split to 25 test split. Number of the LSTMs was 3, and the number of the each LSTM layer was 128, 65 and 32 neurons. So dropout I didn't change anything, and dropout layers I didn't change anything, and regarding the dropout rate, I kept it as 30%, which is the same as the previous one. So the length of the time series sequence I changed it to 100 days, and the batch sizing was reduced to 16, and the number of epochs for training was 75. Let's see if it has performed well. So now let's go to the training insight. So loss trend, the model loss over the epoch of 75 epochs were carefully monitored. So when we see the test loss, the test loss is 0.000778, which is a very slight improvement from the previous model, but a slight improvement on the accuracy is also very important. So after that, the same method was followed, which is the forecasting with the redesigned model. The prediction started sticking onto the real stock prices more meaningfully than the before one. So you can see the visualization of the enhanced result. So in this mainly you can see, as I told you, the blue is the true value and the orange. So here you can see a little more better prediction than the previous model because of changing some of the parameters. So now let's talk about the original versus redesign. As I explained you before, for the first model we had only 2, but now for the second model I considered the 3. Dropout layer was 30. Here also it was, in the second models also it was 30, but the input sequence length, there it was 150, and here it's 100. The batch size, there it was 32, and for the second model it was 16. Epoch was 50. Here the epoch was 75, and the optimizer was Adam, and the loss function was same, mean square error. So what we can do is, what we'll find out is the loss was a slighter improved for the second model. So a slighter improvement in accuracy with the redesign, and it is important. So when we compare the both, the second one was a little much better. So now let's talk about the whole project report. So the project report. So the main we did here is the report explains how neural networks can be employed in time series forecasting by highlighting its capability to interpret and predict sequential information. So in the all about slides, the study has been divided into various sections that the test different models as well as the method for efficiency and accuracy when dealing with the data set. The sine wave simple RNN was emphasized along with the LSTM neural networks which predict the forecast. So the whole project description was divided into 3 parts. The first part was the simple RNN with the sine data. Here the objective was to predict the future values of the sine data using a simple RNN. The approach was simple. The sine wave was constructed using consist of 1000 points generated from a sine function. Here the architecture was very simple. It implemented a 2-layer simple RNN followed by a dense layer of output. So the next one we considered was LSTM neural network. For stock prediction data. Here the objective was to improve the accuracy of the stock prediction, and we designed a 2-layer network, and the result demonstrated high predictive accuracy, but we did consider one more, redesigning it, where we played with the parameters and we could see a little more slight improvements. So what we learned from the whole process is simple RNNs are great at handling on the time series data that have a clear vision, and LSTMs networks are known to perform well in terms of time series data because they have a great ability to represent on the long-term dependence. So in conclusion, this whole project, recurrent neural networks have shown that they can model and predict time series data very well. And for prediction of the waves to forecasting stock price, it was clear that RNNs are flexible and adaptive, especially LSTM. The modified LSTM model demonstrated small yet efficient changes which could be made the model improve its performance. Through this project, I not only gained a deeper understanding of RNNs and LSTM but also realized the importance of designing, training, and evaluating the models of real world scenarios. These learning will allow me to explore more in the areas of neural network and optimizing them accordingly. So this is what I spoke about now. So thank you. I hope you enjoyed. If you have any questions, please do email me. Thank you.